Okay, in this video, I'm going to show you how to work with rational equations. So a rational equation is when you have an equation that has fractions. But before I show you an example like that, I want you to solve this example. I want you to solve for x, for this equation 2x minus 3 equals 11. Okay, did you get x equals 7? Because if you did, you're right. Now I'm going to show you 3 more equations that I want you to solve. Are you surprised? Did you get x equals 7 for these equations too? Because if you did, you're correct. I want you to take a look at these 3 equations, and then I want you to compare each equation to the original equation, which I went ahead and put a square around, really a rectangle. I want you to see, specifically compare each part, like how the 2x minus 3 equals 11, compare that to the 4x minus 6 equals 22, the 10x minus 15 equals 55, and so on. Do you see a pattern? Okay. The pattern I want you to pull out is, I want you to notice that this entire first equation, I have taken each term and I've doubled it. I went to the original equation and I multiply each term times 2. So what about the second one? Okay, multiplied each term by 5. And then the last equation, when it's compared back to the original, I multiplied each one of them times 3. Now I showed you this experiment to prove to you that you can multiply parts of the equation, all parts of the equation, by the same number, and it doesn't affect the value of x. Okay? That principle we're going to use when solving rational equations. So get ready for the first example. In this example, there's 2 fractions. And just by looking at this equation, having these 2 fractions here just make the problem, it just makes it appear to be pretty difficult to solve, especially since we have our x is in numerators and we have numbers in the denominator. And so we're going to use the same idea that if we multiply each part of the equation, 1, 2, 3, all 3 parts by the same number, it won't affect the value of x, but it would allow us to simplify these fractions into whole numbers, okay? And so which number do you choose? The number you choose to multiply is always the least common denominator, or the least common multiple of the denominators. We have the denominator 4 and 3. 6 is a whole number, which its denominator is 1, which we don't really need to factor in right now. We just need to focus on the 4 and the 3. Well, the least common denominator from 4 and 3 is 12. So I want you to multiply each part by 12. And this is how I show my students in class. The first step I get them to do is to draw a set of parentheses and put a 12 above each part, because that's just a physical way to make sure you are going to multiply it by all 3 parts. Okay, so next I want you to write the 12. Now let's write it next to the numerator, because each of these are being multiplied to the numerator. So this will be 12 times x minus 4 plus 12 times x, whoops, forgot to put my little denominator, equals 12 times 6 is 72. Now, you may be tempted to use the distributive property, but I don't want you to do that yet. The first thing I want you to do is to reduce the fraction so that the denominator is 1. This first one, the 12 and the 4, simplifies to 3 and 1. Okay, so now we're going to multiply this 3 times x minus 4 to get 3x minus 12. Okay, the next fraction, the 12 and the 3, simplify to 4 and 1, leaving that with plus 4x equals 72. And now this equation looks a whole lot easier than where we first began, and we can be confident because we multiplied each part of the original equation by the same number, our x value didn't change. So now I want you to collect like terms and solve for x. 7x minus 12 equals 72. And that gives us 7x equals 84. And when you divide 7 by both sides, x equals 12. Okay, let's take a look at the second example. First thing I want you to find out is what is the common denominator. And it really helps if you can find the least common denominator, because then you're working with smaller numbers. So if you look at this example, the denominators are 7, 2, and 14. So the least common denominator would be 14. So I want you to multiply each numerator, each of the parts, by 14. Okay, so we're going to say 14 parentheses 2b minus 3 over 7 minus 14b over 2 equals 14b plus 3 over 14. So if you feel comfortable going just straight to this step by just writing the 14 next to each numerator, that's great. In the previous example, I had you write the 14 in parentheses above each part. That's okay too, but if you feel okay just to kind of start at this step, go for it. Okay, do not use the distributive property at this step. The first thing I want you to do is to simplify so that your denominators are 1. So the 14 and the 7 reduce to 2 and 1. That 2 I'm going to now distribute into the 2b minus 3 to get 4b minus 6. Okay, next, the 14 and the 2 simplify to 7 and 1, leaving us with 7b. And then the 14 and 14 both simplify out, just leaving b plus 3. Okay? Okay, now the equation looks a lot easier. You need to decide, we're going to get all the b's together. I like to get them on the left side and get the constants on the right side. So that is how I'll finish the problem out. Because this 4b and the negative 7b, because they're on the same side of the equal sign, you can collect those together. Be negative 3b minus 6 equals b plus 3. Okay. Next, I'm going to subtract the b over to the left side. And then in the same step, I'm going to add 6 to the right side. Let's see, so that crosses out, this crosses out. 3 plus 6 is 9. Now I'm going to divide both sides by negative 4. Okay, that leaves us with b equals, and notice how the negative sign is in the denominator. That's technically okay. I encourage my students to float that negative to the top, just because how we read a fraction, we would read the answer as negative 9/4. And so to have that negative symbol kind of up in the numerator, I think is really helpful. And don't freak out that you have a fraction for an answer. Remember, this entire problem, the original problem, was fractions, so it is okay if you get a fraction for your answer. Take a look at number 3. If you notice this problem, each of our variables are in the denominator. So this is a new situation, but we can still solve it, and it's still Pretty straightforward. We still need to find a common denominator between 6b squared, 6b, and b squared. And it's sometimes harder to imagine a common denominator when you have variables involved. And so I want to ask you, how can we make all these denominators match each other? Okay, so for example, 2 of them have 6, but the third one doesn't have a 6. 2 of them have a b squared, but this middle one doesn't. And so if we were to get them to all match, to all have a common denominator, that common denominator, it would definitely have to have a 6, and it would have a b, but that b would need to be b squared, okay? And then that would be the common denominator for each of these problems. And so we're going to take that common denominator, 6b squared, and multiply to each of these numerators. And each of the numerators right now are 1, so this is what it's going to look like. It's going to be 6b squared over 6b squared plus 6b squared over 6b equals 6b squared over b squared. Okay, now because each of the numbers in our original equation, the numerator was a 1, we don't have to use the distributive property for this one, so you can go ahead and simplify. 6b squared simplifies with 6b squared to get us a 1. Okay, this middle term, both 6's cancel, the b's cancel, but it leaves a b left over right there. So we have plus b equals, okay, this last one, just the b squares cancel, okay. And wow, isn't this a nice one? We got to solve for b right here. We just have to subtract 1 on both sides. That's not bad at all to get b equals 5. It's your turn. I want you to pause this video and try some of these equations on your own.